Welcome to The Explainer. Today, we're diving deep into microfrontends. We're talking about a really powerful way for development teams to untangle themselves from these huge, messy code bases and start building in a much more flexible, scalable way.
So let's just jump right in with a question and be honest. For anyone out there working on a big web app, does it feel like your UI code base is just slow, risky to deploy, a total headache for multiple teams to work on at the same time? If you're nodding along right now, yeah, you're definitely in the right place. So here's what we're going to cover. We'll kick things off by defining what microfrontends even are. Then we'll take a walk through their history, looking at the old school ways of doing things before we get to the really cool modern stuff. After that, we'll stack them up, compare the options, and finally help you figure out if this whole approach is the right move for you and your team. All right, let's get into it. What exactly is this architectural pattern that you keep hearing so much about? What's the big idea here? To put it simply, it's really just about taking that one giant user interface, that monolith, and chopping it up into smaller, independently owned pieces. So you could have one team that owns just the login page, another team owns the product search, a third team, they're all about the shopping cart. And here's the magic part. They can all deploy on their own schedules whenever they want, but for the user, it still feels like one single seamless website. Now, you can't just start chopping things up without a plan, right? That would be chaos. So for this to actually work, the whole architecture really leans on three core principles. First, every piece has a single responsibility. It does one job, and it does it well. Second, they're loosely coupled. They talk to each other through well-defined contracts, which means you can change one piece without accidentally breaking everything else. And third, high cohesion. All the code for a single feature, it all lives together in one place, which makes it way, way easier to manage. So how did we get to this point? Well, let's take a little trip back in time and look at the old school ways teams tried to solve this problem. And hey, some of these might look pretty familiar to you. Okay, first up, and probably the most common pattern, is what we call server-side composition. This is where you split up your website based on the URL. For instance, your web server, maybe it's running Nginx. It sees a request for your site.com/account, and it sends you over to the app that the account team built. If you go to /blog, you're routed to the marketing team's app. It's simple, it works, but the big downside? Every time you move between those sections, you're getting a full page reload. Kind of clunky. Next up, the classic iframe. You've seen these everywhere. They're perfect for embedding little widgets, like dropping a Google map or a Twitter feed right onto your page. You're basically putting a whole separate web page inside a little box on your main page. And while that gives you amazing isolation, you pay a pretty steep price when it comes to performance, security issues, and oh man, the headaches you get trying to make the styles match. And the third traditional pattern is build time integration. This is where one team builds a cool UI component, packages it up as a library, and publishes it to a registry like NPM. Then, the main application just installs it, just like any other package like React or Lodash. But see the problem? Their deployment schedules are now completely changed together. If that widget team pushes a tiny update, the main app has to pull it in, run a whole new build, and redeploy everything. Not very independent, is it? So those traditional patterns, they all have their limits. And that brings us to the modern approach. And this is where things get really, really interesting. We're talking about a huge shift in thinking here, away from building everything all at once beforehand, and instead assembling our UI live, right in the user's browser at runtime. And that brings us to what's really the state of the art right now. Module federation. This is a game-changing feature made popular by Webpack 5 that lets one application, we'll call it the host, dynamically load and render UI components from a totally separate, independently deployed application, the remote, all happening live at runtime. Okay, so it works with 4 key puzzle pieces. First, you have the remote. That's the app that's offering up a piece of its UI, let's say a product recommendation widget. Then you have the host. That's your main app, and it wants to use that widget. So how does it find it? The host calls to the remote's remote entry file. Think of it like a menu of all the components that remote has for sale. And this last part is absolutely crucial. Both apps use a shared configuration. This tells them, hey, we both use React, so let's make sure the user only has to download it once.
Now, you might also hear about a tool called Single Spa, and it's really important to know where it fits in. Single Spa is basically an orchestrator. Its main job is to help different frameworks, like React and Angular and Vue, all play nicely together inside one single application. But if all your teams are already using the same framework, say everyone's on React, you can probably just skip Single Spa and use Module Federation all by itself.
So we've got all these options on the table, right? From old school iframes all the way to this futuristic runtime stuff. How on earth do you choose? Well, let's get into the trade-offs and give a verdict.
You know, the fundamental difference, the real heart of the matter, it all comes down to one question. When does the integration happen? Is it at build time, where you're using a package and everything gets locked together before you ever deploy? Or is it at runtime, where the code is fetched live, on demand from its source? That runtime approach is what unlocks true independent deployments. And this table here, it just lays it all out so clearly. Look at Module Federation. It's green across the board for the big goals: independent deployments and fantastic performance, thanks to sharing dependencies. But what's the catch? The setup effort is high. That's a big red mark. On the flip side, that server-side pattern, super simple to set up, but you pay for it with lousy performance because of all those full-page reloads. And build time packages? They're kind of stuck in the middle. Performance is decent, but they chain your teams together.
So here's the crucial takeaway. While Module Federation is unbelievably powerful, it's not a silver bullet. There's no free lunch here. You have to be ready for the complexity. And that means you're going to have to get real comfortable with your build tools configuration. You'll need to solve some tricky runtime problems like CSS conflicts or data fetching across domains. And you've got to think hard about operational stuff, like how are we going to monitor and cache all these remote pieces?
Okay, we've talked about the what, the how, and the which. Now for the most important part of all. Let's bring this all back home and talk about you and your team's specific reality. At the end of the day, the right answer isn't a specific technology. It's a deep, honest evaluation of your own situation. How many teams are you trying to coordinate? How desperately do you need those independent deployments? And real talk, how much complexity can your team realistically handle right now? This is a journey. You can absolutely start with a simpler pattern and then evolve towards something more powerful like Module Federation as your needs and your skills grow. And that really just leaves us with one final thought to chew on. Now that you've got this map of the micro front-end world, from the simple to the super sophisticated, what's the next logical step for your application's architecture? Well, that part's up to you.